Question 8. A sample of bromine was analysed with a time of flight mass spectrometer and found to contain two isotopes, 79Br and 81Br. So two atoms of the same element, same number of protons, same number of electrons, but different numbers of neutrons, and hence their different mass values of 79 and 81Br. After electron impact ionization, and that means you're going to bombard it with high energy electrons from something called an electron gun. The electron gun, or the stream of high energy electrons, knocks off an electron from each of these atoms, so they become plus one charge. So you have 79Br 1 plus and 81Br 1 plus. After loss, all of the ions were accelerated to the same kinetic energy, so they've all got the same kinetic energy. They're actually accelerated towards negatively charged plates with holes in them. They travel through a flight tube which was 0.95 meters long. So the kinetic energy of all these particles is always the same in a time of flight mass spectrometer, and the length, the distance of the tube is always the same. The 79Br 1 plus ions took 6.69 times 10 to the minus 4 seconds to travel through the flight tube. Calculate the mass in kilograms of one ion of 79Br 1 plus. Well, let's do that first of all. So the mass of one atom of 79Br. So to work out 1 mole of atoms of 79Br 1 plus. You can forget about the 1 plus, by the way. It's just lost an electron. The mass of an electron is negligible. So 79Br plus atom and a 79Br atom is the same. They've got a mass, 1 mole, and they've got a mass of 79 grams. So that is that number of particles, Avogadro's number of particles in a mole. So if I take the 79 grams and divide by Avogadro's number, which is the number of particles, I'll get the mass of a particle in grams, 1.312 times 10 to the minus 22 grams. But it needs to be in kilograms. It says it wants to be mass in kilograms of one ion. So grams into kilograms, so grams into a higher unit value, a larger unit value of kilograms, then I'm going to divide by 1,000, 1.312 times 10 to the minus 25 kilograms. So that's your first part. Calculate the time taken for the 81Br 1 plus ions to travel through the same flight tube. So I'm going to have to use this information now. I've got the mass of the atom of the ion of 79Br, so 79Br plus. I've got the mass of it. Now velocity is distance divided by time. I've got the velocity of the ion, 0.950. I've got the time taken, 6.69 times 10 to the minus 4. I've now got the velocity of this 79Br plus ion. So I can work out kinetic energy. Now remember, kinetic energy of all the ions is the same. So if I work out the kinetic energy of the 79Br 1 plus ion, then the kinetic energy of the 81Br 1 plus ion is exactly the same. So that's what I'm going to use. I've now got the velocity of the 79Br 1 plus ion from distance divided by time. I've got its mass. So kinetic energy is half mv squared. Half multiplied by the mass, 1.31 times 10 to the minus 25, multiplied by the velocity, 1,420 squared. So the kinetic energy of 79Br 1 plus is 1.32 times 10 to the minus 19. It's in joules. The kinetic energy of all the particles entering the tube is the same, so not entering the tube but accelerated towards the plate, so you make sure that kinetic energy is the same when they're in the tube, accelerated towards the plates. And the kinetic energy of 81Br equals half mv squared is exactly the same. So I've worked it out for 79Br 1 plus, it must be the same for 81Br 1 plus, 1.32 times 10 to the minus 19 joules. Half mv squared, so I'll multiply both sides by 2, so now instead of half mv squared, I've got mv squared is 2 times 1.32 times 10 to the minus 19, 2.64 times 10 to the minus 19. So I've now got mv squared. I can work out the mass of an 81Br. It's 81 divided by Avogadro's number. That gives me the mass in grams of one atom, one ion. 7981Br is 1.345 times 10 to the minus 22 grams. Convert it into kilograms by divided by 1,000. Now we've got the mass of one 81Br 1 plus ion is 1.345 times 10 to the minus 24 kilograms. So now I've got the mass. So mv squared was 2.64 times 10 to the minus 19. So the mass, 1.345 times 10 to the minus 25 times v squared is 2.64 times 10 to the minus 19. So put that line twice, so v squared is 2.64 times 10 to the minus 19 divided by 1.34 times 10 to the power 25, 1.96 times 10 to the power 6. Square root both sides, so v squared is the square root of that, 1.4 times 10 to the power 3. And now I can finally say that the time I can work out time because I've got v. V is 1.43 times 10 to the power 3 here. Distance is the length of the tube, 0.950, that's not changed, divided by time. So time is 0.950 divided by 1.4 times 10 to the minus 3, 6.80 times 10 to the minus 4 seconds. Explain how ions are detected and relative abundance, that means how common they are, how many of them there are, is measured in a time of flight mass spectrometer. When the ions hit a detector plate, then the plus ion accepts an electron. It turns back from a plus ion into an atom. It gains an electron, accepts an electron. So the ion hits the detector and accepts or gains an electron. That creates a current, and the larger the current, the greater abundance of the ion, the more ions are hitting that plate.